Hello everyone, good morning. Let's start. Okay, so first of all, I am very glad to have you all here this morning. My name is Diego Diaz from Grupo Dex. Some of you already know me by emails and so on. So it is very nice to put a face on you, or at least to hear you this morning. I will be conducting this event titled Agricultural Soil Quality and Water Management, which I hope will be of your interest. This research mission has been organized by the Dordogne Chamber of Agriculture with the support of Grupo Dex. So, as I said, I will be the one moderating this session and introducing the participants. In this research mission, that is the fourth that is being organized within the CCC project, 5 European projects from different European programs will present their work and will share their best practices that can serve as model for other countries. All of them will have 20 minutes to share their initiatives with us, and they will be available for questions for 5 minutes at the end of each presentation. Now, well, I see you all have it done already, but I will kindly ask you to please turn off your microphone and your cameras and only switch them on when it's your time to intervene in this session. For questions and answers, you can write them in the chat, and my colleagues Maria Orzonas will ask them at the end of each of the presentations. So that was all from my side, and now Nicolas Fedu, as representative of the Dordogne Chamber of Agriculture, will pronounce some welcome words to introduce the session and give some context to it. Thank you.
Thank you, Diego. Hello, everyone. Agriculture is directly impacted by climate change. The sector present in the department such the spring crops, fruits plantation, market gardening, and winery are all of production for which the rise in temperature, the decrease in water comfort, and the increase in the frequency of drought will have an impact on the yield and the quality of products. The issue of water resource management is crucial for the future of perigord agriculture. The Chamber of Agriculture of the Dordogne has been involved in the dynamics of Interreg project for more than 10 years. CCC opens the file and the knowledge through the analysis, evaluations, and capitalization of European projects in risk prevention and management. The objective is to guide the next generation of transnational cooperation programs. The research mission takes place today in video conference with the context of COVID-19. Our structure is honored to be able to carry on this seminar, which we hope will be rich in exchange and future collaborations. The Chamber of Agriculture of Dordogne participated in the selection of projects with all the partners to highlight good practice. We conduct interviews with project leaders who will select for their relevance and representativeness. These projects will be presented to you. We thank them for their participation as well as the support of partner DEX. Thank you. Have a good seminar.
Thank you, Nicolas. Now I will want to give the floor to Lawrence, our first speaker, who will give an overall presentation of the CCC project. So the floor is yours, Lawrence.
Okay, so thank you very much and welcome to you all and for joining the conference. I'm going to sort of talk around the CCC project itself. Diego, do you want me to share my screen, or do you want me to, are you going to do it?
You can do it, Lawrence.
Right, I just need to get my screen up. Right. Is everyone able to see that presentation?
I am, it's okay.
Yeah, okay. So as I say, welcome to the research seminar, national seminar for agricultural soil quality and water management. I am going to be presenting the project and the partnership and what we've been doing, so you have a better idea of the CCC project and what its goals are. And really, the main aim of the project is around capitalising climate change projects in risk management for a better resilience. And it's looking at all the projects that have been funded through the European Union on climate change adaptation over the past 13 sort of years. So I'm going to talk firstly about the changing climate. We know that the climate has been changing. Ed Hawkins' very useful visual graphic of how the average temperatures have changed over the years. Actually, you can now download this for your individual countries and for your individual areas within your countries on a website called showyourstripes.info, which I put up there. And you can see in the UK, the story is the same for all the partners within the CCC project in terms of how the climate has been changing over the years. And when we look at that globally, we see the classic image that kind of all of us, I'm sure, have seen, that the temperature of the planet has been warming considerably. And that in itself is having exacerbating the risks we're having, whether it be wildfires, whether it be droughts, whether it be heavy rainfall and floods and the associated water pollution and erosion, both within our rural environments, but also our urban environments. So not surprisingly, over the last 20 years, society has been working out how to adapt to this changing climate and how to adapt and become more resilient to these multiple risks. So the EU have set up various programs that have funded everything from environmental to social to economic changes. But the CCC partnership have analysed over 300 projects that have been invested in through various different programs. And this is a summary of some of them. So over 1 billion euros has been invested on climate change adaptation since 2007. And of that, the majority comes from the research programs. But you can see that purple section, the Interreg funds, is all of the both the Europe level program, the area level programs, of which Atlantic area, which funds the climate CCC project, is one of, and the cross-border areas. So over 270,000 million euros has been invested over a quarter through the Interreg program alone. Now, if we look at that by land use and start trying to understand those 300 plus projects, we see that sort of almost a half are made up of kind of what we would call, they're not described as having a land use. And that's because of the fact that they are often governance programs or policy programs or purely research based programs rather than specific to a certain land type. But over half are specific to land types and land uses, and of those, not surprisingly, 15% of the projects are on the urban area where all the people are, but we're also getting significant projects on forestry and on estuary and marine areas, and that's perhaps not surprising given the way we manage our land has a huge impact on the estuary sort of and the marine and the freshwater sort of zones of our countries. We can also look though at the type of risk that those projects are assessing when they're looking at climate change adaptation. So again, the sort of categories of other is where it's not a specific risk more the governance of risk, and the brown section is where there are multiple risks being looked at. But for single issue specific risks, again, we see the issues of flooding and drought as being some of the biggest problems. So too much water and too little water. But we're seeing obviously things like wildfires, erosion, heat impacts within there, and the health impacts associated with them. So that's kind of the global picture and the sort of European picture of what we've been investing in. I've also been asked to give a sort of more localized example of how that dynamic pans out in relation to soils in the West Country. So we are the West Country Rivers Trust, and we are based in the southwest of England. This is a satellite image showing after heavy rainfall, showing the amount of soils being washed into our oceans and into the English Channel. That is productive soil that takes hundreds, if not thousands, of years to generate. So it's vital that we look at how that is being lost and why it's being lost. Now, the UK is doing a huge amount on climate change and risk, sort of the increasing risks from climate change. And so this is something that's come from our Committee on Climate Change. And really it pulls up the issues to our infrastructure in terms of flooding and erosion, and the fact that we will have sort of more heavier rainfall in shorter periods of time. We will find ourselves with higher temperature extremes and stronger winds, as well as rising sea levels. So all of those will have significant impacts to the UK infrastructure. And the UK spend a lot of time looking at the infrastructure of towns, cities, railway, road networks, telecommunications. The question is what about the landscape scale infrastructure? So if we look at our landscapes, they have been changing. This is a map and a satellite image of the same area of land, a small kind of 1 kilometre square catchment in the southwest of England. Now, in the 1950s, the map on the left shows that there were this small area, there were 45 small fields. There was a lot less nutrient usage in those fields, and there was little compaction because of the fact that we weren't asking as much from those fields in terms of the amount of food being delivered from them, the machinery being used on them. So what that means is that was a relatively low intensity of use. Whereas if you compare that to now, a lot of those field boundaries have been taken out and the fields simplified. So the drainage within those catchments is more simplistic, but also we have a lot more nitrogen, phosphate and potassium, as well as pesticides and other agri-chemicals. We also have far more compaction on these fields because our, as I say, our farming operations have increased because our technology, our tractors and our infrastructure allows us to go out there at times of year where it's easier to do damage. So not surprisingly, when we look at our landscape and when we look at things like how our water changes, this is a diagram of how the amount of water within our rivers changes over a period of time. So the Q is for the discharge, the amount of water, and what we see is in our sort of less intensively managed sort of historic systems, water would be released slowly after a flood event or rainfall event, cleanly, and it would also be returned to a larger base flow in our rivers. Whereas now we have, after a rainfall event, our catchments respond quickly, the water is often more dirty, and when they do drop back down, they are lower than they would normally be because there's less water in the system. So this means that we're getting muddy floods within our catchments. We have a lot of heavy soil loss coming with our rainfall every year. We're now seeing that now. that the winter rains and autumn rains are here. But it also has a significant impact for the farmer. This is an example of severe soil erosion, where a pasture field has the water has come off of the surface and then gone on to an old maize field, and then sort of pushed a gully through it, causing severe erosion and soil loss. This is a more, as I say, a more extreme example, but we see this across the West Country, especially on these light sandy soils. So we need to think around how we talk to the farmer around and the landowner about their assets, their soils, and actually think around this is an asset that most of us will have, although we may not use it at the moment during COVID, and that is something like our car. So we maintain our cars for lots of reasons. If we have a well-maintained car, it increases our fuel efficiency. It can get us from A to B, does the job that we want it to do. And it also, a well-maintained car reduces our stress, so we don't have to worry about, are we going to get from A to B? But it also gives us, those are private benefits, but it also gives us public benefits that are important reasons why we maintain our car. If we have a well-maintained car, we have less emissions. There is less road debris on the road. We don't have bits of our car falling off. We have less oil leaks that effectively will get into the river and wash off. And we're a reduced risk to others. A well-maintained car is unlikely to sort of fall apart and cause an accident. So that's why we have to maintain our cars. That's why the government regulates the maintenance of cars. But what about the maintenance of soils and the benefits of that? Well, most farmers know that if they maintain their soils, they'll improve their nutrient efficiency. They'll get higher yields from their field, and they'll also have reduced stress. So they won't worry about their crop failing, or they won't worry about the implications and the risk of being fined or prosecuted if they were to lose their soil. And those are private benefits for the farmer that improve their economy, their bottom line. But there are also public benefits that are derived from maintaining our soils. They maintain the summer flows, as I said earlier. They decrease the flood risk potential for our towns and villages. They can capture carbon, which is an increasingly important part of climate change mitigation. They also reduce the pollution because of the fact that the water isn't running off of the surface and taking other agri-chemicals or oils or other materials with it. And they provide valuable habitat for the microorganisms that live in our soils. So it's fundamental that we have to address soils as part of not only climate change mitigation, but also climate change adaptation for the reasons I've explained. So in the West Country, the way we do that within some of the projects we're involved with is looking at a lot of our farmed environment. That's mainly because 80% of our landscape in the southwest is farmed. And the image here on is something we call good farm, bad farm. And it highlights all of the practices that can be found on some of our farms on the left-hand side, such as overstocking, inappropriate infrastructure, growing crops too close to the river without having buffers and on slopes. And on the right-hand side, it shows some of the things we work with farmers to address. Now, a lot of these have a huge impact on climate change adaptation and climate change resilience, whether it's slowing down our water within the fields themselves by having appropriate soil structure, whether it's putting in enough buffers and habitats to recreate the field density that we used to have, or whether it's educating the landowners in terms of taking understanding their farm and measuring their farms, as well as things like the infrastructure and the impact infrastructure has on those farms. So what we will hear from today is all the projects that work in this sort of area in terms of how to influence that dynamic and who starts paying for those changes. Is it just the farmer and us trying to regulate the farmer, or more likely, is it society that is trying to pay for the improvements, whether they be water quality and drinking sort of water from the water companies, whether it be public bodies wanting to pay for flood risk mitigation and drought, or whether it be wider society interested in aspects of fisheries, or the final one there around the carbon offsetting impacts potential for changing our landscape. So as I say, within the CCC project, really our role is to try and understand all those projects that have been happening and better communicate some of the solutions to adapt to a changing climate to protect us from a future that's already here. So really, I welcome the presentations and thank everyone for being able to present today. And also thank you for Chambre d'Agriculture for hosting the virtual meeting. Whilst it is always enjoyable to have these meetings face to face, one of the direct impacts of not doing it and having it virtually is we've saved ourselves 4 tons of carbon through having a virtual meeting rather than us all having to come to Bordeaux. So thank you very much, and I look forward to today's presentations and happy to take any questions.
Thank you, Lawrence. That was a very interesting presentation. Thank you. So I would like, first of all, to remind to all the participants to ask any questions they may have through the chat, and we will ask them at the end of the presentation to the speaker. So the next one to speak is Santiago. Santiago is project coordinator of the Piragua project within the co-financed by the Interreg POCTEFA, Spain, France, and Andorra. So there you go, Santiago. The floor is yours.
Thank you. Hi everyone, and thank you for organizing this meeting and for letting us have the opportunity to present our project. Yeah, so I'm the coordinator of the Piragua project, which belongs to the Interreg POCTEFA program. It's a program between France, Spain, and Andorra, and it focuses on the Pyrenees. Focuses on the water resources of the Pyrenees in the context of climate change and what are the adaptation measures for this big territory. First of all, I must apologize because my presentation is in Spanish and French, which are the official languages of the Interreg POCTEFA program, although my explanations will be in English, and I hope this won't be a big issue for you. Okay. So we are nine partners from the 3 countries involved in the call. We are basically universities and research institutions, but we also have 10 associates, which are mostly the water agencies that manage water resources on this large territory. And this is our of course, we focus on the pier in the center of this picture, but the water resources which are generated on this mountain range influence or are used in a much larger area, which goes from the from Zaragoza or all the Ebro River, which is one of the main rivers in Spain, to all the way to Bordeaux in France. So the influence of this mountain area is much larger if you consider where these water resources are used. And that's what we are trying. One of the things we want to highlight on this project is the importance of these mountain areas as water resources generators. So what we expect from climate change, these are things that we are already seeing. We are expecting that climate change is going to reduce the average stream flow and rivers, but the subterranean of aquifers. We know that this monthly regime is also changing, is already changing. We are experiencing higher discharge in winter months. We are having a snow melt earlier in the season, and then the summer low flows are larger. It's taking longer, and they are more pronounced. These changes can also modify the physical and chemical characteristics of the rivers, and they are impacting already biological aspects of the Pyrenean waters, influencing their quality. So what are our objectives? We have three main objectives. The first one is to characterize the water resources of the Pyrenees and evaluate their future evolution. The second objective is to identify adaptation options against effects. Our third objective is to make the knowledge available for a broader public, not just the technicians or scientists. So the program for this presentation is, first I will focus on what we know about water resources on the Pyrenees, from the Pyrenees, what we know about their actual and their future evolution. And then I will talk briefly about adaptation strategies from several case studies. So what we know, we are collecting all the data, and we are talking with the different management institutions, and we have made a report about how the water resources of the Pyrenees are used and how much water do these mountain regions generate. There is a very heterogeneous use of the water resources from the Pyrenees, basically the south of the chain in Spain. There's a much stronger, much more intense use of the water resources of the Pyrenees as compared to France. Also, the water use is very different. It's predominantly for agriculture in the Spanish side. In the French side, is more diverse. We have agriculture, of course, but we also have drinking water and industrial as sharing a large part of the water use. And also there are differences in the origin of the resource. In the Spanish side is mostly surface resources through large systems of reservoirs, while in France it's a mix of surface water use and underground water use. All these different modes of managing the water resources are going to have a profound or very important effect in climate change scenarios. And this is one of the aspects we are considering. The water resources of the Pyrenees are managed by 6 basin or large basin agencies from 3 different countries. So there are different legal frameworks, institutional frameworks, and different modes of interpreting the law, different ways of organizing the citizen participation, etc. So it's very difficult to consider the water resources as a whole, even if geographically it makes sense, but from the point of view of administration, it's much more complicated, and we need to deal with that. Fortunately, we have all the water managers as associates to our project, and they are coming to the meetings, so we are working with them, trying to see the similarities and where they differ, and what they can learn from each other with respect to climate change adaptation. We have compiled a data set of more than 100 stations from all the stations available from the different administrations. We have made a work of homogenizing the data and organize how we can compare data coming from different administrations, because they are using different methods and maybe different ways of measuring the flows. We have developed, we have defined a series of climate change indicators, which I'm not going to go through all of those in detail, but we have defined or proposed a set of indicators of climate change for water resources, either surface and groundwater resources, and we have made an analysis, a trend analysis over time to see the changes in the last decades. This all refers to observational data. We have come with some conclusions. We are now developing one of the documents, but what I can tell you is that basically, in general, we see a decreasing flows, either the low flows or the high flows. They are decreasing in the massif. It depends what time period or what time frame you choose. Of course, as you move into the present, it's more difficult to see a trend. But when you look back from the 50s or 1960s, there is a clear decreasing trend. We are also analyzing the piezometric data, which refers to groundwater. It's much more difficult because there are fewer data and they are more incomplete, but we are doing the same analysis on the groundwater. So what are the preliminary conclusions? We have some, the water resources of the Pyrenees are very important for a much broader area, which affects millions of people, and it's been affected already by climate and also by land use change, which affect differently the different areas and different economic sectors. We have developed a database comprising the different countries from both surface water and groundwater. We have this data set guarantees that there's a homogeneous, good quality of the data. And we propose to use this network of stations as observation points for future climate change effects. And we have developed some climate change indicators which cover the key elements of the water balance of the mountains. Also, in order to better understand what's going on in terms of the water balance of the whole massif, we are using different models. We are not only looking at observations, but we are using models, hydrological models, which allow us to better understand the whole how the whole system works. We are using 4 models currently: SWAT, Soil and Water Assessment Tool, SACER, Hisbalan, and a conceptual recharge model. I'm not going through all these models in detail because it's fairly technical. But why are we using different models? Well, first of all, because each model focuses on one part of the hydrological balance. We could say that each model does some part of the hydrological balance very well, but lacks other parts are less well represented. For instance, SACER and SWAT are very good at describing the surface water balance, the surface part, and the interaction between land and atmosphere, while Hisbalan and recharge model focuses more on the groundwater infiltration. So that's why we use different models, and so we can compare and we can assess whether the model uncertainty is large or not very large. So this is the modeling with SACER. It's a hydrometeorological model. This is the modeling with SWAT, in which we model each basin separately. This is the model with Hisbalan, which is more focused on the groundwater, and in this case, we are selecting a number of basins as representative basins. And finally, we have a conceptual recharge model, which allows us to understand changes in the recharge of the aquifers. So basically, what are the objectives of this modeling exercise? Well, first of all, we want to we want to make projections with the models. Once the models are calibrated and they can in a satisfactory way represent the current processes, hydrological processes, then we could fit in the projected climate change scenarios, so we can project the changes in the hydrological balance of the Pyrenees. And for that we are using the data, precisely the climate change scenarios from another POCTEFA project, which is the CLIMPY project, which has generated a number of climate change projections for the Pyrenees area. So with the models, we are going to be able to calculate, to produce future scenarios regarding water resources. So what are the preliminary conclusions? We are still working on that. We are now running the models for the future scenarios. But basically, the modeling of the hydrological balance at the scale of the Pyrenees will allow us understand better the ways of the system, how it works, even in those basins which have no data, no observational data. We are going to, one of the objectives is to understand, to do an attribution of the observed changes to different causes, such as climate change, land use change, and vegetation cover. And finally, this will allow us to generate scenarios, water resources scenarios in the future, which we're going to use in the case studies, in the individual case studies. And I move on to the next section of my talk, which is about adaptation strategies. So in the first part of the project, as you see, we are theoretically looking at the whole Pyrenees area and trying to understand what are the observed changes in water resources, but also trying to project, to make projections for the future. But in the second part of in the second half of the project, we are looking at adaptation strategies, and we are taking a very different approach. We are not looking at the whole basin, but we are looking at 7 particular case studies, which focus, each one of them focus on a specific topic in one specific region in the Pyrenees. And I'm going through the 7 case studies very fast. Later I will zoom in one of them so you can understand better what we are doing. So we have we have case studies dealing with the use of water in agriculture, focusing in Aragon, in this area here in Spain. We are also looking at the hydropower production, which is very important in the Pyrenees. We have a very beautiful case study in France where we are looking at how climate change is going to affect the management of the hydropower dams and how this will affect other water uses downstream the rivers. We have a very interesting multisectorial analysis in Andorra, where they are modeling how the competition between different water uses will increase in the future, while Andorra will move towards their plan of being almost self-sufficient in terms of energy production from hydropower. And we have another case study linking water and forest management in the Bidasoa catchment in Navarra. And we have a case study about sensitive ecosystems in the headwaters. This is a moor system, a pit system, a high altitude system in France, in Vic des Saux. We are also considering, because water in the Pyrenees is a very important resource for tourism in natural areas, such as the case of the Ordesa National Park in Spain, and we are also studying how climate change plus high touristic pressure might affect the water quality and quantity in this national park. And we are also looking at the extreme events related to water, basically extreme floods and so on. And we have developed a database of extreme events, of fast floods in the Pyrenees area at the municipal level. And we are conducting simulations to try to understand how this risk might change in the future, considering not only climate change, but also the trends in buildings and population, etc. And here we have also developed a citizen science application, which is an experiment to see how to involve the people into this research. So I'm going to zoom briefly in one of these case studies so you can understand a bit better the approach and what we are doing. I'm going to go through this very fast, but I hope you will get an idea. So in this case study, we are working in this system here is between Gallego and Cinca rivers in the central Ebro Basin, which is a big area which contains the largest irrigated surface in the European Union. It's called Riegos del Alto Aragón, which is a system with more than 130,000 hectares irrigated, which can feed either from the Gallego or the Cinca rivers through a series of reservoirs, very large reservoirs, here La Peña, Sotonera, Mediano, El Grado, which can feed the system mostly during the summer. This is the largest system in the European Union. It's a very interesting case study because it's very complex, and how the water resources are managed in the system is very interesting. Of course, this area here, the valley, has a very dry climate, while the upper part, in the mountains, is very humid. So this irrigation system is basically being fed with the water resources which are generated in the mountains. We have climate change projections, as I showed you before. So the question is how climate change is going to affect this system in the future, and how to increase the resilience of the system in the future. And for that, we started working with the farmers directly. We have conducted a number of sessions with them in order to understand what is their perception of climate change risk to their farms, and what are their preferred adaptation measures. And with these experiments, we have come up with a number of adaptation measures which are preferred by the farmers and are perceived as being the most effective. And what we do is we have designed a rather complex modeling cascade of models in which we model how climate change is going to affect the generation of water resources in the headwaters of the catchment, and then we link that with a management tool which is called AquaTool. It's a model that tries to operate the dams in a way which maximizes the water used by the farmers, and also, well, urban supply and so on. And finally, we can fit this model with different scenarios, with different adaptation measures, and see what the changes are through a number of indices that we have defined. And I have time. Basically, what we do is for different emission scenarios and for different time frames in the 21st century, we are presenting what are the expected outcomes in terms of the sustainability of the system. And basically, what we have said, development of new infrastructures, new reservoirs in the rivers, or small reservoirs within the irrigation system itself. These measures will not be able to maintain sustainability levels as the system has today. And the only way to maintain the sustainability of the system is to implement it additionally to implementing water saving measures. We are now working with the farmers, trying to pass them on this message, and trying to work with them with a set of water they might, they think, they believe might be more successful in the future. Or maybe they will be able to tolerate a lower sustainability of the system, which implies more frequent failures in the future. So through these 7 study cases, I just showed you one example of one of the 7 case studies, but the methodology is very similar in all of them. So we are working with the main stakeholders in the areas. We are focusing on one problem when we are using our simulations of future water resources generation, and we are seeing what are the options on different economic sectors. And so through these 7 case studies, we want to understand better what are the adaptation strategies, not the ones that we scientists might think that would work, but what are the strategies that the stakeholders believe are more successful. And we are trying to spread this to different economic sectors. And finally, we want to use these conclusions and to upscale them at the scale of the whole area. So, yeah, that's all from my part. I tried to fit in within 20 minutes. Sorry if I was a bit, if I took a little bit more of that time. Maybe we have time for some questions. I don't know.
Thank you, Santiago. No, it was perfect in timing. Thank you. Yes, we have a few questions. My colleague Jonas will take them from the chat and ask them directly to you.
Thank you.
Hello, Santiago. Hello. As Diego mentioned, I will be in charge of collecting the questions from the chat and transferring them to you. So we have one question from West Country River Trust, Lawrence. Let me tell you what he wrote. You said you had 100 data centers. I wasn't sure exactly what data they were capturing, but are these at a sufficient density to allow you to understand leaf change, or do you need more data as there are cheaper proofs on the market?
Yes, that's a very good question. Well, we have selected, well, the data I was referring to on that slide it's a stream flow, okay? It's a surface stream flow, discharge on 100 river events. And yeah, of course, the density of data, it's what there is. I mean, if you go back to the 1950s, there's like 12 gauging stations that we are using, only 12. Of course, there are many more than that, but most of these gauges are affected either by large reservoirs or large water uses upstream. So we are basically considering only basins which are natural or close to natural, so that are not heavily modified by human use. So they don't have large reservoirs upstream, etc. So we were very, very careful and very strict in the requirements that we set among those gauge basins. Sorry, those gauges. There are more than 700, and we have removed most of them to finish with a number of gauge stations that are affected by human. Why is that? Because otherwise we cannot look at natural space.
Yeah, just one small. You have the sound problem sometimes. Maybe if you could switch off your camera, the sound would be better.
Perfect. I can do that. No
yes,
problem.
Yes, sometimes, but maybe it's important. Thank you.
Sorry. Yes.
It's okay now. Yeah.
Good. So yeah, I finished it. There's another question.
Yes, there is another question from Joris Devent. He said that thank you for your talk. I understand you used a sustainability index in the last case of study of irrigation. How did you determine this index?
Yeah, that's a very, very good question. Hi, Joris. maybe perhaps I can share with you, or all of you, if you're interested, the paper in which we explain the details, because it's a bit technical. But basically, this sustainability index is a geometrical mean of 3 indices. One is so there are 3 indices that reflect how the system, how frequently the system will fail. And a failure means that the system is not able to release enough water to the users during 1 month. So how frequently this occurs, how long are the failures, and what's the resilience of the system, how fast the system recovers after a failure. So there are 3 indices which we have combined into a single one, which is called a sustainability index, and it's a geometrical mean of the. But if you want the more precise equations, I can share the paper with you or with anyone interested, of course.
Thank you, Santiago.
Of course. At the end of the session, all the materials that you provide to us would be available for further use.
Perfect. And of course, I'm open to any question. You have my email.
Just a last question from Jean-François Berthomier. He says that farmers in Spain are not often willing to use proofs like capacitance proofs as we are using on larger scales in France. Is it going to change soon? Here we believe we are saving 20 or 30% of water with same results economically without reducing surfaces with irrigation.
Yeah, Jean-François, what kind of pros he refers to? I understand he refers to water stress, to measuring water stress in plants directly. Is that true, Jean-François? Can you confirm? You are referring to
yes,
water stress.
We are using here capacitance probes like Santec probes or other to measure the moisture in the profile of the soil down to 60 meters.
Yeah, I understand. Yes, that's a very good question, and actually not in this project, but we have another project in which we are experimenting precise irrigation and even deficit irrigation in fruit trees and also olive trees, and we are using soil, but also water stress sensors in the plants, so we can much better and much more precisely use irrigation. And it's very interesting when you see the results of these meetings with farmers. That I didn't have time to go through all the measures that they discussed, but the second and third measures were modernization, and modernization 2.0 precisely refers to the use of in-field sensors and so on. So and also information technologies such as drones, etc. So they can much better apply water when it's needed, and this came in third position right after improving the water regulation capacity. So it's very interesting that the stating that they want to start implementing these kind of measures, although I must say that it's very, very experimental and very rarely used now, but they are interested according to themselves. Okay.
Great. So there is maybe a possibility to have a link with you, because we have some experience on that, more than 20 years using these type of probes, and we can share that.
I would be very, very interested in knowing better about what you're doing. So thank you very much, Jean-François.
Great. So I think we arrived the time for the coffee break. It is a very short one, just 5 minutes to stretch our legs. And we will be back with the presentation from Annabel Sanchez from the Center for Ecological Research and Forestry Applications, CREAF. So,
okay, thank you very much.
See you in 5 minutes. And thank you, Santiago.